Okay, so it's talking about two triangles and basically whether these triangles are congruent. So let's go to the notes. So here, so I put the exam number 2 notes right at the top of the Unit 2 module in your Canvas course shell. So grab that, and I sent an email to you with the exam 2 notes as well. So let's refer to those. So here's the exam 2 notes. And the very first thing is the rules for triangle congruence. And I've said a couple statements there. I pasted them over here where I can write on them for you. Go there. There we go. So here we go. So here's the exam 2 notes. Let's talk about triangle congruency. Now, what does congruency mean? It means identical. So two triangles being congruent means that they are identical. They're exactly the same in every way. All angles are equal. All sides are equal. So if two triangles are congruent, that means they're completely identical in every way, meaning all three angles are equal, all three sides are equal. Yeah, let me say that. Let me put a 3 in there. All three angles are equal, all three sides are equal. So, okay, so let's take a look. So now what does it take? What does it take to prove that two triangles are really and truly identical to each other? Well, you don't have to have all 6 pieces of information, it turns out. Let me write that. To prove two triangles are identical, to prove two triangles are identical, we do not need all 3 sides and all 3 angles. What do we need? We only need 3 pieces of information. Excuse me. Excuse me. 3 pieces of information. That's all we need. Like right here, side, 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 or side, or angle, side, angle, side. That's all we need. I'll talk about those bottom 2 in a second. That's all we need is 3 pieces of information. And it turns out that any 3-letter combo works. You can basically have any 3-letter combo you want, except there is one exception, 2 exceptions, except not AAA. AAA is a no-go. If you have 3 angles and 3 angles, it turns out that's not enough information. That just proves the 2 triangles are similar. We'll talk about that in a future section soon. But not AAA and not ASS. And there's an easy way to remember that. That's the bad word. So I'm being a little goofy, but that'll help you remember that as well. So, and that's probably an easy way to teach kids as well. So basically, any 3-letter combo works, except not AAA and not the bad word. And of course, or SSA, you can say the bad word forward or backwards. That's the same thing. It doesn't matter which way you say it. So not the bad word, forward or backwards, and not AAA. But all other 3-letter combos work. See, here's the bad word, by the way. See, that's the bad word backwards. Right? That one doesn't work. And you can see right on the diagram. See how those two triangles are not identical? I think this was a nice little picture I got off the internet. So see how this has a side that is 6, and they both have a side that is 6 and a side that is 11. They both have two sides that are equal, and they both have an angle that's 30 degrees. So they both have two sides and an angle that are the same as each other, but the triangles are certainly not identical, right? You can see that little arc they're drawing? What they're saying is you could put the 6 right there, or you could put the 6 way over there. That's still 6. And that's two different triangles, right? Can you see that? Is that making sense? They're saying this triangle here is not identical to that, even though it's not identical, even though they have the same, two sides the same and an angle the same. They have two sides and an angle, all the same. Two sides and an angle, but they're not identical. So two sides and an angle, the bad word, forward or backwards, is not sufficient. It's not enough information to prove that two triangles are identical. But all the other three-letter combos are side, side, side. If you know three sides, like this side, the little marks mean they're equal, right? This side is equal to that side. They both have a single mark. Like maybe this is, I don't know, 6 and this is 6. And then this side here is maybe 10 and this is 10. See the double mark? And then maybe this other side is, I don't know, 12. No, it's got to be smaller. Huh? Maybe this side is like 8 and this side's 8. They have three equal sides. Well, that's called side, side, side. And that's enough information. Enough information for what? To prove that the two triangles are identical in every way. Yeah, but we don't know about their angles. Well, their angles have to be the same. That's what we're saying. That's what it means to prove something, right? You've found that it is true. So if all you need to know is three sides in one triangle are the same as three sides in the other triangle, and then the angles they have no choice, they must all be the same. If three sides in one triangle are the same as three sides in another triangle, then the angles have to be the same. Or over here, side angle side. Now, what's going on here? We have two sides, like maybe this is, I don't know, maybe again, this is like 8 and 6, 8 and 6. Two sides are the same. And maybe this angle, this looks like what, I don't know, 100 degrees. Maybe this is 100 degrees. So we're saying two sides, see the marks? Two sides and an angle in between them. If you have two triangles that have two sides and an angle in between them the same, then those two triangles have to be identical. That's what this statement here, this equals with the squiggle above it, that means congruent or identical. That's the symbol for congruent or identical. So if you have two sides and the angle in between, that's enough information to for sure prove that the two triangles are identical in every way. What about the third side? We don't know the third side here. Well, what we're saying is it has to be the same. There's no choice. It has to be the same. It can't be different. And the other two angles we haven't been shown, they have to be the same as well. The triangles have to be identical in every way, as long as you know side, angle, side. That's enough information. If you just know two sides and the angle in between, side, angle, side, that's enough information to prove, to demonstrate that two triangles are identical in every way. All the sides and all the angles have to be equal just by knowing two sides and the angle in between. You can kind of feel it a little bit, right? If you know this is 8 and you know this is 6 and you know how big the opening is between them, well, there's really no choice for how big the other side is. It's kind of determined already. And so are the angles. There's only one way to do it. Those two triangles have to be the same triangle. And then down here, angle, side, angle. So, maybe this is like, I don't know, like 30 degrees, and this is 50 degrees, 50 degrees. Two angles and the side in between. Maybe this is 10 and 10, right? Two angles and the side in between. That's enough information to prove the triangles are identical in every way. You think, well, yeah, we don't know the third angle. Well, it has to be the same. And what about the other two sides? We don't know those yet. Well, they have to be the same. Those two triangles have to be identical in everywhere because we have two angles and the side in between. And then finally, this one, two angles and a side not between. See how that S is not between? Looks like we know this angle's, I don't know, maybe 40, maybe, well, here, let's make it, maybe this one's like 30, this is 40, 30, 40. Then we know this side, like this is a 10 down there. So see how we have two angles and a side not between them. See, it's not this side here. Those sides would be between the two angles. But it's a side down here, not between the two angles. That's why it's AAS, a side not between. I'm not going to really deal with this in the homework. I mean, it's pretty simple. It's a right angle triangle. If you have a right triangle and you know the hypotenuse, this is the hypotenuse, and some other side, that's enough. Like I said, we're not going to actually cover that in what we're doing. All right, there it is. So basically, moral of the story, final takeaway, you only need 3 pieces of information. Any 3-letter combo works, except 2 exceptions. The AAA doesn't work. You don't see AAA up here. And the bad word forward or backwards does not work either. But any other 3-letter combo other than those is enough to prove 2 triangles are identical. All right, so getting back to question number 1, what do we have here? Well, looks like we have this angle, like maybe this is, I don't know, you know, maybe this is 50 degrees and this is 50. I have no idea. I'm just making up stuff. But they're telling me those are equal. And maybe this is like 60 degrees and this is 60. So we have 2 equal angles, but that's all we have, huh? This is just angle here, angle here, angle here, angle here. This is AA. It's not enough info to prove 2 triangles are identical. AA is not enough information to prove 2 triangles are identical. You need 3 letters, don't you? And they didn't give us any more information. All they gave us was those 2 angles in the 2 triangles. So what are we going to say then? We're going to say the triangles are not congruent, and they don't even look identical, do they? Are not congruent by, and then here you just say not enough information, and then so triangle, and then here you're supposed to say again not enough information because we can't prove those 2 triangles are identical. So that one's just not enough information. There we go.